buddy, howdy. Look at what has come home to daddy. Do I have a story to tell you about this box? This box is epically legendary in my mind. I built this way back when I started this business, way back when. There used to be a white BBI sticker that was right here. Somebody's removed it. There used to be a sticker that went across the bottom that said the build number and everything. Somebody removed it. There's going to be a link down below in the description for the original YouTube video build for this little guy. And there's also going to be down there a link for the Stickman rebuild of this box. Let that sink in for a hot minute. So I get this call on the phone one day from a guy. He says to me, BB, I want to hire you to build me, I don't know, an 8-pill. With them 50-volt transistors in it. I said, okay. And this is, this is in the very beginning. Very, 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 very beginning of things. And so I blindly said, sure, no problem, we can do it. And then he threw in this stipulation. This is what the kicker is. This is hilarious to me. Let me unplug this thing here real quick. He says, I want you to make it so it works on a 110 outlet. And I said, I can't do that. He goes, why not? And I said, because it's going to take like our 30 amp 110 outlet. Because this thing's going to make a whole lot of jam. More than what we can pull out of this outlet, this little, 15 amp outlet. And he goes, oh, don't worry about it. So I kind of have to worry about it for safety reasons, right? And he says to me, he goes, no. I have a 30 amp 110 volt outlet for my shack. And that's what I'm going to use to run this thing with. Oh, okay, no problem. And I'm all excited because that was in the very beginning when I was excited and I wanted to go prove to everybody I knew how to build boxes, and I discovered this new groundbreaking technology with these different transistors, which, come to find out, you guys, there's nothing new here underneath the sun. These are actually military BLF components, or BF components. I'll show them to you. I didn't show these off because at the time you could buy these transistors for, they were like $25 a piece. Now they're $400 a piece, the transistors that are in this thing. And people approximately treated them like they were $25 a piece transistors, and now they're incredibly expensive parts, like incredibly expensive. I think I got like a dozen of these left. I was buying them in bulk, right? So anywho, I was all excited. So I blindly took it and I didn't ask any other questions. So I get the amp all put together, I do the YouTube video of it, and I'm all, look at what I've built. Oh, called up EPD and had them custom make each one of these transformers because I figured out very quickly in the beginning that if I was to get one transformer to do the job for all 8 transistors, I was never going to get it to fit inside this cabinet, which I'd ordered for it. So I had literally build to the cabinet, not have the cabinet built to the product. It's silly. It's not the way I work anymore. So I'm underneath the impression this guy's got a 30 amp outlet. Well, come to find out he does. We're going to circle back to that here in a minute. You're going to find that this is funny. This story is very funny. This is part of the learning process of learning how to deal with customers. I learned a lot from this box. This transformer here is the PRI 230, 220, 215. Okay, secondary 1.5 volt 15 amp. Okay, secondary to that, number 2, 12 amp at 12 volt at 2 amp. So what we're saying here is this is the primary, or the secondary. Primary is 110 volt, and the secondary is 42 volts at 15 amps. Well, 15 amps for each 2-pill section. Now, in the 12 volt world, that math doesn't really add up, but this is a continuous duty transformer. So that means I can put 15 amps on this, or I can surge this the way we're going to run it to a whole lot more. Okay, all of that doesn't mean anything. There's technically just barely enough power supply in here. Barely. But remember, we're on 110 volt extension. So I get this thing all boxed up, and this is at that point, this was the heaviest thing I'd ever shipped out of here, by far. I get it all boxed up, get it like triple boxed, because this thing weighs probably 55, 60 pounds. And I get it sent out of here. Off it goes. The guy gets it, never calls me. And I said, all right. So I called him. I said, dude, how's it working? He goes, great. Man, I was killing them guys last night on the radio. I said, okay. Now this is after me having it for like a month and a half and me talking on it for almost a month and using it on the air for like a month because the guy didn't have the money together for the shipping. He barely had enough money to buy the box. And I think I asked only like, you gotta remember, this is in $2,010. I think I wanted $2,100 for this thing in that time frame, okay? So I come back to him like 6 months later and I said, okay, it's ready to ship. Here's your video. It took him like 2 or 3 months, maybe 4 months to get the money together, the couple $100 for shipping to get the thing. So he gets the thing. I'm all excited. So then he calls me about a week later and goes, man, this thing blew up. And I said, cool. I said, so how many watts are you putting into it for drive? And he goes, I don't know. I'm like, what? He goes, yeah, I don't know. I said, well, how many amps is the, or how many watts is the radio or the amplifier putting out? He goes, I don't know. I said, dude, how could you not know this? And he goes, well, I don't own a watt meter. What? He goes, yeah, I don't own a watt meter. I said, well, you don't know what your SWR was? Nope. And I had no words. I was like, what the what the fuck? I was like, okay. Well, something come apart. So he saves up his money. He sends me back the amp. I get it back, and he blew all but 2 transistors out of this thing. Toasted it. I mean, like, launched them. I put 6 new transistors in this thing. I cut him a good deal on the parts. I tried to cut him a good deal on the shipping, and I get the thing sent back to him. In the interim, I'm talking to him on the phone. I ask him, so what were you using for a driver? He goes, well, I had a 667 going into this. Oh, my heart skipped a beat. I'm like, in the YouTube video, I showed that this thing was getting hit with a pair of 2290s, and I was using a 25 watt radio. So you take like a Cobra 29, you put it into a pair of 29, into a pair of 2290s on a 2-pill that's not volted at 12 volts, and it's just a couple 100 watts of drive, right? That's really all this thing needs. And you're gonna get like 3,500 watts out of this, almost $4,000 out of an 8-pill. I'm like, dude, you can't do that. That's too much drive. He goes, well, I had the variable all the way down on the front. I'm like, dude, it's too much drive. So I hook it up and I ran it. It blew up. It's your fault. How's this my fault? We went back and forth on this. So, make the story even better. He gets it back. He hooks it up. He runs it for unknown amount of time and proceeds to blow it up again. Well, the next thing I see is this thing is over at Stickman. Stickman did a video on this, and Stickman rebuilt this box. And he told him, hey, there's not enough power supply here. So what we're going to do is we're going to drop 2 transistors and we're going to turn it into a 6-pill. Because all he knows is he's reading this here. And he's not thinking, hey, our components run at 50 volts, not 12. So we're talking 3 times the amount of voltage, almost double the power output and power, and the current draw is less. I applaud Stickman because what he did was good, the work was good, amp is still currently in working condition. He sends it back. The guy then calls me and says, hey, this piece of shit you built me still isn't working right. I sent it to Stickman. Stickman supposedly rebuilt it. I watched Stickman video. He charged me a bunch of money. This still ain't right. I want to send it back. And I said, dude, you better send that back to Stickman. If you have a problem, it's no longer my burden. I mean, honestly, let's think about this for a hot second. So the next thing I know, this thing shows up on eBay. Now, let's pause for a minute. The second time around it blew up, after I sent it back, I get one little tidbit of information out of this guy. Now please let's not forget, he never had a watt meter, didn't know how much drive he was putting into it, driving it with a 667, didn't know what his SWRs were, and he supposedly was running it on a 110 volt, 30 amp plug, so it shouldn't technically have been starving for juice. Well, things aren't quite the way they seem on paper. Talking to him on the phone, I get out of him the fact that he's in a plastic pre-made shed in his parents' backyard. I couldn't make this up if I wanted to. He's on a plastic pre-made shed in his parents' backyard, which is as far from the house as they possibly can get it. There's a 100+ foot extension cord that's plugged into a single 110 outlet in the house that runs all the way around and runs to his shack. He's got his lights, his heater, his TV, his computer, and all his radio equipment plugged into this one single outlet. Let that sink in for a minute. On paper, it sounded like everything was good, but in reality, no watt meter, doesn't know how much drive. Supposedly he's on a 30 amp outlet, sure, at the end of a 100 foot extension cord on the backside of his parents' backyard in a plastic shed, overdrives the crap out of it, doesn't know what his SWRs are. And he was mad at me because he says what I built him was faulty. So this thing, he puts it on eBay. Now, there used to be a sticker on the lid too, if my memory serves me, but somebody has messed that off, and I mean, this cabinet looks like it has just been through a war zone. It's missing one of the foam. Why would you lose the foam dust cover? Look at the inside of this thing. It's got duct tape, wire, shit everywhere. It didn't look like this when it left here. No, sir. Anywho, it don't matter. The guy on eBay sees this. He's very familiar. He's a fan of Stickman. He's a fan of mine. He sees this amp. He knows exactly what he's got. Well, please note, the story continues. This amp is cursed, and we're going to break its curse right here down today. That's what we're going to do. This guy purchases this amp and proceeds to have one of his guys, an employee, call me up and says, I work for this guy. I want to send him this amp. I send you up this amp to have you completely rebuild it. And I said, bud, this is at the beginning of the first time I was completely overloaded with stuff. But I had nostalgia for this box. I got nostalgia for this box, I can't lie. I love this thing. For what it does and its size, the amount of power it produces, amazing. It's amazing. So I told him, yeah, I'll take it on, but I'll have to look at it when I get there. So the guy sends this thing up to me back in 2019. This has been here for a minute. It shows up with his, not the guy that I'm actually working for, not the customer, not the guy that bought this. The guy that bought this is owns some business, very wealthy, whatever, I don't know, got a whole lot going on. Doesn't have time to deal with me directly. Okay. His buddy sent up all his information, but didn't put any of the actual customer's contact information on this thing. And the dude that sent this literally called me once a month. And I told him, I said, hey man, I've got 18 months worth of work in front of you. When he sent this up, I said, I can get to this when I can, but right now I'm not making you any promises. Well, the guy that sent this up, that's my only point of contact, not the actual customer. It's crazy. I know the story's crazy. It's very long, convoluted, takes forever to get through. I know. I got so frustrated with this dude. I was like, man, you know what? Don't call me anymore. Have the actual guy that I'm doing the work for give me a ring and we'll figure something out. Well, I don't hear from that dude until last October? Last October. And I'm like, okay, here's what I'm going to do. I'm going to cycle this in with all the other repairs. I'm not going to put you in front of anybody else. We're going to cycle this in and we're going to eventually get to it. Now that I finally got the contact information for the right customer. Well, guess what? Here we are, almost 2 years later, because nobody wanted to communicate with anybody like an adult or share all the information, and it's back. You can take an eye and check out the Stickman video. You did good work. You can take an eye and check out my video and see that this thing is going to do a whole lot more power when we're done. That is the end of the story. No watt meter. No watt meter. Doesn't know how much drive. Driving it with a 667. Well, what the? 30 amp extension, 30 amp outlet on a 100-foot extension. What the holy? I'm stoked to have this thing back over here on my workbench. I'm here to tell you. And I'm excited to. I'm just excited. This thing makes me happy. Okay, so power's off. Relay's off. We're going to use the bench 490. Let's go over here and let's make sure this thing works first, you guys. Let's do this test. Okay, so 1,000 watt slug and peak, 1,000 and average, 5 watt slug and reverse back from the bird, 10,000 watt dummy load. Oh, hey. Oh, now. Oh, nitty. Let's not start with a 490. Let's start with a 2950 first. Here. Really? Hello? 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 Okay, so I got to clean the relay too. Hello? Audio. Hello? Audio. Dirty relay. Started tapping on relay and it took right off. Okay, so hello. Bench is down on 12 volts. Let's go ahead and turn the box on. We're putting about 10-15 watts in it. Gauge the amplifier. Hello, audio. Hello, audio. Just getting about 800 watts out of it. Hello, about 900 watts out of it. Here's our input tune. Hello, audio. All right. So, to me that seems low. At least based off of what it should have done when it left here. So 15 watts in, 800 watts out. Remember, this is only a 6-pill, you guys. 6-pill 50-volt box. This is some old technology, I'm here to tell you. Old. Okay. So, now we're on the 490. Hello, audio. So now we're going to hit it with about 100 watts. Hello, audio. Zoom on out. Let's reach down here. Let's turn on the amp. Zoom back in. Now we're going to do well over 1,000. Hello, easily. Okay. Take a multiplier, put it up 2 eggs. Hello. Hello. 2,000 watts. It should do way more than that. Let's take it down to 5. Hello. 2,000 watts. Should do way more than that. Let's go here. Let's change it from the way it was when it came in here. Hello. 25. Hello. Solid 25. Okay. Still, to me, that's a little bit low. It should be, I mean, the top end of this box is going to be about 3,800 if I remember correctly. Hello, audio. It's just a little out of tune. All right. So let's grab up our voltmeter. Voltmeter. Let's put this up here for everybody to look at. Stick that there. And we'll clamp on here at the filter cap. So we're idling at 61 volts. Hello. We're pulling to 54 volts. It's still low. Hello. And our input tune is way out. Let's go look at this. Hello. It should be almost flat. Okay, so hello, audio. 1, 2, 1, 2. Still a little low, in my opinion. Okay, so those are our 2 benches. Roughly about 15 watts of drive, makes about 900 watts per. Oh yeah, hey, let's re-verify that we actually did good here. Let's disconnect that. Let's reconnect this guy here. We'll go back onto the 2950. Now, if we remember correctly, with our 15 watts of drive or whatever, hello, how'd it go? Hello. Oh yeah, it picked up power. Picked up about 100 watts. Hello. All right. Making just about 900 before. Now we're making just about 1,000. This thing, it has had an interesting life. We get down here and we look. Let me scoot us forward. There's a burn mark that wasn't here when it left here. Poor thing. You see the burn mark down here? That thing has been rough. It's had a hard life. It's been abused. That's all I'm going to say. Abused and abused. I don't remember this being spread out like this. We look around on the inside, we can see that this is the coax that got added on the splitter. And also this would be the coax that got added on the output side. So we're going to put it back the way it was. We're going to put this back the way it was. Now the customer requests that I put it back the way it was, do any of the necessary repairs that I'd like to do, and also wire it for 220 so it's got a prayer of living. And I am all about that. So what we'll do is we'll split the leads, because these are all independently rectified, and then there's some together after the rectification process. So we'll use that breaker, and then I'll put a contactor in here, I think, to switch the other leg. But we'll power these 2 off the black lead, probably these 2 off the white lead. So this will have its own independent 220 volt source. This will have its own independent 220 volt source. We're going to leave those submerged rectifiers in there because they're technically big enough. I mean, if it was, I had more room, a lot more room, I would stick these big rectifiers that I use now. But believe it or not, those rectifiers have never failed. It's always been the pills. And I think that has a lot to do with, well, many different things. I noticed that the capacitors have changed. They've been removed. There was capacitors on the output transformers. Those are all gone now. We'll build new splitters, new combiners. We'll build 2 brand new 2-port combiners and put that back the way it was. Yeah, let's, I'll clean these pill pockets out real good. We'll go over into the box of non-supported parts, and I'll grab a couple more transistors and we'll slap them down in here. We'll get them soldered in. Let us begin. Let us officially, 20 minutes into the video, begin. Well, it's 3 o'clock in the morning. I'm gonna go in and go to bed. Tired of looking at amps and talking to people about amps and thinking about radio. Here's where we're at. I can't rebuild this the way I built it initially. I've learned more. I feel strongly about certain things. Changing the combiner setup. I'm using better capacitors because now I've got access to better technology. We went ahead and we put the metal clads on top of the output transformers. We lifted this whole section out. All the power wires came out. We redid the whole combiner setup, so now we got a 2-to-1 and a 2-to-1 tied down to boards, so nothing's going to move. Makes it a whole lot more stable, a whole lot safer, by the way. Rebuilt the input splitter, rebuilt the output splitter, hooked everything back up the way it used to be, and configured ourselves for our setup, for our inputs. We're going to do that tomorrow. And I got out the giant book of knowledge and book of secrets here, and I went back and I looked, and I designed and built this thing on 5/13 of 14. So this is over 8 years old, this box. 8 years ago. It's crazy to me. It's absolutely crazy to me. Seems like this was just a couple years ago when I built this box, but it's been floating around for a long time. I think it's on its second owner now for sure. Very dirty. This thing needs a bath. The cabinet needs to be painted. It's going to get new stickers, new vinyl, all that kind of stuff too. It's all full of cobwebs. It's had a rough life, man. I'm not kidding you. Mother and dad's extension cord, 100-foot long. Come on. I couldn't make this up if I tried. I was like, you what? Yeah, man. Yeah. I can hear the dude's voice in my mind right now. Okay. So tomorrow, we're going to take the Panasonic transistors that are in here. Oh, yeah, these are Panasonics, by the way. These are the very well tested, tried true transistor it's the BLW96. Now, the last time I checked in on these, they were... Oh, RF Parts is selling them for a frickin' fortune. Now RF Parts is sold out of them, but... Let's see, BW96. No, wrong part number. I'm tired. BLW96. Shoosh. I just said it too. If we type this in and we click on price, they're about $70 each one of these transistors. You can buy them from Mouser, DigiKey, Find a Chip, Poke Goldfish, believe it or not, AliExpress. It's really cute. The ones that are on DigiKey don't even have any writing on the lids. They're just complete Chinese rip-off components that I'm sure kind of work. For a hot minute, even Ampleon was making them. Ampleon, you know, being the company that is famous for taking over the BLF product line in the land of MOSFETs. Philips, made by the Philips company. They're a good part. I didn't want to share with everybody what they were when I first built them, because everybody was really busy trying to copy everybody else, and there was a lot of shit talk going on, and nobody could believe that I could develop any kind of product on my own. Well, I had help, of course. I had people teaching me shit, so I utilized that shit and I made some more shit with it. So it is what it is. But this entire series of amplifiers and the MOSFET run of parts was totally driven by cost per dollar per watt. The MOSFET parts and these components, I could build more power at a cheaper rate and still have high reliability. Facts. At the time, the only thing we had was a Toshiba transistor in the early generations of the DEI. As we all know, the DEI transistor turned out to be shit. Absolute shit. And that was an HG product, by the way. That was the first generations of the HG transistor were labeled DEI, believe it or not. The HG's come a long ways. It's still, in my opinion, very lacking in a lot of departments, but I mean, I've got a whole YouTube series, a video series that's getting ready to come out about another side project I have going on in the background. I'm not quite ready to talk about it, but I take the powerhouse industry standard Toshiba, I put it on a curve trace machine and like, let's go look at all these other components and see how they stack up. And they all fall woefully inadequate past down below the HG transistor. I mean, like horribly down low below the HG transistor. So I'm so tired I just said that wrong. I know I said that wrong. They all fall woefully below the Toshiba transistor standard in their breakdown in voltage gain, structure, internal structure, thickness of transistor tab. I mean, they all fall down. There's a reason that the Toshiba was king forever. And it's still king today. I don't care what anybody has to say. They're just incredibly expensive, hard to find, because RF Parts is out. The long and the short of the story is these are good components. They've been around for several decades now. This is like a 30-year-old legacy component, 40-year-old legacy component. And I could build this and get 3,000 watts of power out of this. And at the time, we're looking at the Toshiba at its price point of like $80 a transistor at that time when this was built. Remember, we're looking at dollar to dollar, like $1.30 per watt, where I could do this for about 75 cents a watt. And the MOSFET was the same thing. Now, when HG kept going forward and kept making their parts better and making them better and better and better, eventually we got to the DEI product line, which was strong enough that we could go and start using those reliably, and people having a lot of success with them and enjoying them. You're welcome. And we were able to get that price point down below the MOSFET price point and down below this price point, down to where it's like what we enjoy today, which is about 50 cents a watt, dollar per watt generated. So, you know, economics change, parts change. We got a lot of stuff. This whole ass into this amp from here back and out to the tailpipe of things is completed. Tomorrow we're going to drop the transistors in. I got to go and pull all these caps out and test them. There's several of them that show significant damage for being dragged, soldering irons hitting them and stuff. I think Stick took all these transistors out, tested them all, put them all back together. And I've kind of just gauging off the solder work that's in here, I can tell that probably one of these blew up, like this one here, and another one of these others blew up, and he had to rob the transistor from here to make this 6 transistor section work. But yeah, we're gonna get all put back together. We got the combiners all built up over here that are gonna go in it tomorrow for the input side, or the input splitters, I mean not combiners. Look at the splitters all dropped in, and yeah, we'll see how we hang out. If I remember correctly, this thing made like 3,400 watts, 3,500 watts pretty reliably. So first we'll get it running on the 110 volt Harbor Freight electrical connection here, because that's what this is. This is a Harbor Freight 110 outlet. I don't know where this came from, but it's not what was on it when it left here. And then we'll switch it over to 220 and see if there's any major power output gains. I doubt there will be, but there might be a little bit. So we'll see. On that note, tomorrow here we come. My God, can I talk? I was just reviewing the last little video clip. Jeez, I never shut up. Okay. So this cabinet is messed up, man. You can see where they took their fingernail and they scraped at the paint. Looks like somebody used it as a coffee cup stand at some point. I'm going to take and sand all this back. We're going to repaint this and make it look all pretty again. Get all the cum stains off the side. I mean, literally, there's like, I don't understand. This was perfect when it left here, but it's okay. We're going to make it all good again. We're going to make the cabinet great again. And as far as these fans, I don't know what the deal is, why they're held on with duct tape. I don't. And they're broke. We're going to put all new fans in this thing that actually move enough air to cool this whole unit down. These guards that were on here, one's missing its screen, and they're all these broken. I got a couple more of these, but I don't know if we're going to go this route. These were all mostly cracked, but the case is getting an overhaul, and it starts now. So the mystery continues. I go and I get this whole thing put together. I go and I run it. I throw a carrier with it. Don't modulate it, nothing. Just throw a carrier with it. If we come over here and look, we'll see the whole output section of this has changed. There's 2 new doorknobs that are in here to get enough capacitance. The inductors have changed on the output. Here's the old one. I don't know where Stick got this from, but this wasn't the one that was in it. I even went back and looked at the YouTube video. I've had a lot of problems today, and I want to document those problems, because you look at things on the surface and you assume, right? You assume things are just the way you left them. Well, there's been some fingers in the pie here, and I'm not saying anything negative against Stick in any way, because the guy got the amp, Stick got the amp, from the customer, and you know, Stick's going to change whatever he's got to change in here to make it work. The Stick's gone now, so I can't call him and say, hey Stick, what'd you do? I'm here playing catch up. So I turn this back into the 8-pill and I go and I run it, and I add these 2 transistors, and we're keeping with the theme. We're putting the black on top of the transistors because it just goes with the theme. You all know what the part is. I just told you what it was, so it's not like I'm trying to hide anything. I just want to preserve the look on the inside of the box. Oh, and the cabinet came out. Oh, the cabinet came out looking like brand new. Oh, I mean, it's pretty. It came out looking really nice. So I get to the point where I'm running it, and I'm like, okay, so I go to do the output tune, and I kept getting heat on this side of the resistor on the output side. Well, that hooks up to this section, and I'm like, why? What is the problem? What is the problem? Well, the last time I seen this amplifier, the guy kept blowing these 2 transistors. He'd pop this one or pop that one. Well, Stick went and turned it into a 6-pill, as we all know. And I honestly think it's because they couldn't figure out what was going on here with this 2-pill section. Well, I think along the way, Stick also changed the input transformers, because I was sitting there looking at these, and I'm like, man, those sure look like type 43 to me. So I pulled one out and I measured it, sure enough, type 43. So okay, no problem. I use all type 61. Okay, at least it says what it says in the book of secrets when it comes to this amp. So I went and I got 4 brand new ICA type 61 input transformers, put them in there, and the imbalance quit here, but then it showed up over here on this resistor, and it would heat up on this side, so it was telling me there was still some kind of weird funky issue with this 2-pill section. So I took it all the way down to the copper, transistors out, whole 9 yards, put it all back together, and went and ran it again, and when I ran it again, it popped this pill, and I went, oh, okay, there's some serious issue going on here. And I mean, I checked the 10 ohms, I checked the 1260 puff worth of capacitance here, I checked every cap, I pulled the transformers out, checked the wires, looked at everything, unwrapped everything, looked at it, put it all back together, couldn't get it. I'm like, what the hell is going on? And it was just constantly an imbalance coming from this side. Now, I've been out here dicking around with this thing since 7-ish this morning, and it's now 5 o'clock in the evening. I'm like, what's the difference? What's the difference between this 2-pill section and that 2-pill section? I mean, the transformers are out. That gives you a visual clue. I've already measured these 2, and they match. Look at this. This is going to hurt. This is going to hurt. So, this is the transformer that comes from this side of the board. .8 UH. .6. That's the difference between having a full wrap in that transformer and without a wrap in that transformer. It's about 2.5 to 3 unihenries. Same number of turns. It's not the wire. I took the wire out of this and put it in here. Flip-flopped them back. There's something wrong with this transformer. And the only thing it could be is either this has got a piece of type 67 in it somehow, or it's got a piece of type 43. Now 43, depending on who the manufacturer is, can have a very shiny sheen look to it. Slightly different sheen and texture to the transformer, an actual piece of ferrite. Depending on the manufacturer, so you can't tell visually. The only way you can tell is by measuring it with an induction meter and looking at what you got for unihenries. I think there's a piece of type 67 somehow in here, in this particular transformer, and that's what's throwing this thing off. But that's a huge difference between, I mean, that's totally explains all the problems I have. at this minute, right here. Now we know the input transformers are changed. We know that these got changed at one point or another. Okay, don't care. Stick gets to do whatever he wants because, you know, he's making the amp work. That's not my mission. My mission is to put this back the way it was when it left here. Well, when it left here, this thing made great horsepower. And the problem was is if you overdrove it, it would always blow one of these two pills in the end. Or if you got it too hot, like decided you're going to play a musical carrier with it, it'd blow a couple pills. Well, I mean, you expect that from any amp. But this here, this took me a hot minute to figure out. I even called one of my buddies over there at Big Rig Radio, Zane, and I'm like, dude, I got one that is just blowing my mind. I'm sitting there and I'm looking at it. I'm spinning each one of the beads because I've had one where the beads were cracked. It's enough to separate them and make them a little bit different than each other. He's like, have you tried flip-flopping the transformers? Like taking this one out of its position and putting it over here and taking this one and putting it over here? I'm like, no. But that made me think, I haven't measured it. So I was out running an errand. I had to walk away from this for a minute. I went out, ran an errand, and I came back and I immediately grabbed my LCR meter and I hooked it up and I went, jeez, man, that is a huge difference. That's a totally cause all kinds of imbalance issues. Now, the problem is that this transformer has got what they call a rolled or crimped end on it. So it's not like I can desolder the plates and then check each one of the beads and find out where the bad seed is at. We're going to do that after the fact. Mark my words, we're going to do that down the road. But as it stands now, I got 4 new transformers coming for this thing, and we're going to change them all out. Because I want this thing to work as smooth as a Swiss watch when it leaves here. This one here, according to the notes, this one here is a 14.7, and this is a 14.6. And this one here is a 14.6 or a 14.5. And this is a 10.2 unit henries. Achha! I don't consider this entire day a loss. 1, I taught myself something. 2, I get to teach you all something. And 3, the product's going to turn out to be fine. So therefore, the day is not a loss. It's not a loss. Even though I spent all day dicking around with this, this is one more tool in the toolbox, the way I think about it. Well, since we're waiting on parts, I'm going to get the fans all worked out on this thing and get it all buttoned up. And when we come back, the next segment should be with the new transformers installed, and we can have a conversation about what it does for power. Okay. Bear with me, it's been 4 or 5 days since I worked with this last. This, I believe, is the one that had... Well, you know what? Let's not do I believe. Let's physically do the tests and see what we got, because this has piqued my curiosity. Okay, this is the one that had the 10.5 UA to it. Okay, this transformer. And this is the higher UA. 14.6. This is the other transformer that we haven't tested yet. 14.9. .3. So in theory, I could run these two together. In theory. And then in theory, I could run these two together. But the reason I'm double checking this, that's so weird. I should have had a double imbalance going on. And now it makes sense why he was running, when he was running them in a 6-pill setup, each stage was its own separate universe. So, these are the new transformers that I had overnighted. .8. 10.8. .7. 10.8. I'll take 4 of exactly the same versus mismatching parts. Now, there's going to be 1 or 2 amongst you that are going to throw the foul card. Wait a minute. I can see with my own eyes these have got capacitors on it and these don't. Doesn't make any difference how it reads. Doesn't change the inductance at all. Let me prove it. .4. Let's disconnect that capacitor completely. Completely disconnected now. Okay. I'm going to put caps on these. I'm going to stick it back here in the amp. And we're going to retire these old soldiers and say, hey, thank you for your support. Thank you for your service. But there's seriously something awry here with this transformer, and I believe it's this transformer. Or no, actually, I guess it'd be these 2 transformers, wouldn't it? These are all 10.8. These are all type 61, we know. .8. Set this farther afield. There we go, 10.3. Okay, there's something off with these transformers. And I do honestly believe that's a huge amount of inductor difference. It kind of makes me think if these are type 61, and these might be type 43. Either way, that's enough for it to present a major, hysterically major problem to the situation. So let's go ahead and let's do the switchy-do. Now that we know that we've got type 61 on the inputs that are all tested and matched, and we know there's 61. And we'll go ahead and we'll rerun the test with all of the exact same output transformers now. Tested, verified, same inductor value. And let's see what we get. Okay, so here we are. Everything is back the way it should be. We did some upgrades to it since you guys seen it last. We put the new transformers in it and got it all tuned out. And it's amazing, the tune turned out to be exactly what it was last time. Oddly enough. I mean, I went back and I looked at the YouTube video. And I really looked at it thick and hard. And then I went, okay, well, come on, out of the floor. There we go. Oh, sorry. Had to move the camera. Apologize, everybody. So, I really looked at the original YouTube video. I actually went back and looked at the original footage because I still got it, believe it or not. And also went and looked at the other 8-pill I built. And I thought, man, I'm going to put some flybacks in this thing. Help guard it from overdrive. When I first learned how to build these, that was generation 1. This amplifier, actually. I was taught that the flybacks, all they did was dissipate gain. Well, come to find out later on down the road, that's not their function. But because the voltage on these transistors is higher, and because the transistors are set up with a different impedance to them, we have to use a different level of resistance, and 200 ohms works out to be pretty good. 250 to about 260 would probably be the absolute minty mint, but 200 will work just fine. I can't believe how much changing out those transformers made a difference. Now, listen, there's a couple different things at play here. So we understand that the stickman way of building boxes is not technically the most efficient thing in the world, right? There's a reason that if we take a stickman amp and put it on this workbench, let's say like a 2x4, instead of pulling 120 amps, it's going to pull like 190 amps. And it's going to make the same amount of power on the watt meter. The other amount of power that it's going to make, the rest of that current's getting used up as heat. The circuit isn't very efficient, by any means. Okay, so then we go and we plug in one of my 2x4s, and it makes about 120, maybe 120, maybe 115, maybe 120 amps worth of draw. Makes the same amount of power, runs way cooler. Now that's just a passive observation. Okay, I'm not saying there's anything wrong with the way stickman built at all. I'm just saying that there's a little bit more efficient modern ways to do things, and when we apply that efficiency, that other 50 or 60 amps worth of draw, we can use it to do other things with. Now, if you want to rewind and go back in time and go look at what this thing was pulling for current when it was just a 6-pill, all you have to do is look at the voltmeter that we had plugged up, and it was dropping down to like 45, 47 volts, which is fine. It's still well within this power supply's range. As far as I can tell, I don't know what these data stickers mean. Right now we're running on 110 volts. There's more than 42 volts of output potential going on here. I don't remember the whole story. Guys, this was 7 years, 8 years ago, 9 years ago I built this box. The notes that I was looking at that said 8, or 2014, whatever it was, 2000. Then I go back and I find another iteration of this same amplifier back in 2013. So then if we go and look at the YouTube data, it says 2013, 14. So I'm like, no, wait a minute. I mean, this is original OG. But if we look at that, it was dropping way down over here when it was a 6-pill. So now it's an 8-pill. And we're going to put the same amount of drive into this amplifier that we were putting into it as a 6-pill. And we were getting 1700 watts out of it. Put the amp in bypass. That's in 5x, by the way. Net meter's in 5x. 1111. Same 100 watts worth of drive. We're using a 955. So let's go ahead and put the amp into operate. Hello, audio 1, 2. So now we're seeing 2,900 watts with 100 watts of drive versus 1,600, and the power supply is still at 53 volts, 52.5 or whatever, 4. And things are running a whole lot cooler in here. Whole lot cooler. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Hello, audio. Let's go look at the input tune we got going on here. There's the front face of the striker. Zoomed in too tight, sorry. 5-watt slug up here. And then we're going to look at the front face of the striker. Hello. 1 bar. And like nothing in reflect on the bird meter. Okay. Everything's happy. I mean, everything's really happy. Peacefully, calmly, blissfully happy. Let's grab another meter. Sorry, I tripped over the stand. I apologize. Let's grab our new fluke. Our new fluke. All right. Let's pull the cap off that now. Here, we'll throw the probe in here. Is it going to stay? Yes. Let's put this new probe here. Hello. 1, 2. So what I'm showing you here is that the line voltage isn't sagging way down neither. 118.7. Just goes to prove we're not juicing the amplifier, number one. And number two, everything is still within spec range. And what I mean by that is at 110 volt outlet, yeah, it's like a true, a lot. Friggin' 6 gauge feeding this outlet that's underneath the bench on a, coming off the one of the 50 amp taps on my service box over there. I rated it at 30 amps. It's a little bit more than that. So I kind of feel vindicated in a way. Like, this is exactly the way it was tuned in its birth video. The only difference that's in the tune is I added this extra doorknob, but in the same breath it compensated by one, trimming the capacitance tube, and two, it's barely even interleaved. I brought it with the doorknob. I didn't want to rely on this because the kV is a little bit too high. I've learned that since when I built this box. I was totally in love with these capacitor tubes. I still am, but you got to be very careful how you go about using them. In a higher kV environment, I mean, if you're pushing 5,000 and 6,000 watts past one of these, you want to make sure you have the one with the higher Teflon wrap. That's what this one is. It's only 86 puff picofarad. In the same breath, I don't want to rely completely on this cap. I don't want to have any breakdowns. So I've taken the tube out. I've sanded the inside of the tube. There's a lot of stuff that's gone on behind the scenes where I've sat here and just went, how can I make this better? And what have I learned since I built the thing? Which has been a lot. Like when this went out of here, this had the polypropylene mylar style capacitors. Now it's got metal clad on the outputs. And of course the output sections on each one of the 4-pill sections is also metal clad to ground now. Just a couple of small little things. And the values didn't change. The styles of caps changed. The inductor stayed the same. This inductor stayed the same. Added a little bit more capacitance here. I had to compensate for that because, once again, this and that and this, that, and the other thing. Added like another 15 puff for the capacitance here, and it laid right down. Now, I don't have a Stryker 4300 anymore. That's what I originally tested this with. It was a Stryker 4300. Or not Stryker, but the Connex 4300, pardon me. Now, I've got a Stryker 490. Which I absolutely love. So now the 490 on the higher voltage that we're running the bench on at the moment is going to do around 200 watts. Oh, about 210. Let's see, let's go to 2x. Hello, yep, about 210. Hello. Stays linear. That's all I care about. So, the question is, when we go and we hit this, are we going to see anything over 3,000? We've come up about 50 watts in drive. Hello. 111. Oh, hey. There, buddy. You got to turn the amplifier on. Okay. Hello. Hello. 1-1. Hello. We'll take 3,300 watts. Reliably, smoothly, quietly, and calmly. And I would smile all day long. Let's hit it more from a straight angle. Hello. We're at 51 volts still. I feel vindicated. I really feel vindicated. For a long time, everybody thought that I built this power supply too small because I didn't show this in the first video. We're at 51 volts, you guys. This is a 50 volt max component. We still got 1.5 volts worth of load that we could put on this thing. The transistors can still give us more. I wonder what it'll do. Okay, so I brought the bench 2 pill into line. And let me show you what we're putting into this thing for drive now. Should get a little more out of it. I bet another couple hundred watts. We're reaching the top end of what the transistors can do. I mean, honestly, we're talking like 900 watt 2-pill. Let that sink in for a minute. So about 3600, somewhere in there. I know when I first built this and I was talking on it, because the guy, I used this for like a month before I sent it to him. I remember getting 34 to about 37 out of this thing pretty consistently, roughly. I mean, roughly. So we're on 1X at the moment. So I'm only going to hit this with about 250-ish watts for the most part. Let's go back down to 5X. Okay. I bet 3400 is all we're going to get out of it on the bench. Yeah, got to get all the data points in field of view there, Luke. Okay, here we go. Still at 51.6. I do remember somebody once saying that the power supply was too small. And then I remember reading freaking hundreds of Facebook comments. Man, that guy's an idiot. He doesn't know what he's doing. Why does anybody send him his stuff? He doesn't know how to calculate power supply bills. Blah, 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 blah. You were saying? That's the closest you're ever going to get me to talking smack about anybody, especially somebody that's not with us anymore. I like him. He was a good guy, very smart, very kind to me. And it has nothing to do with him. It's the about dozen class clowns that run around and just basically hate everybody. And what they don't realize what they're doing is they're dragging the hobby down for everybody. And I mean, they hate on everybody. It's not just me, they hate on everybody. And they do it usually with incomplete data, like the guy that bought this box had like 100-foot long extension cord going out to his plastic shed that he had all his stuff plugged into. And I have no doubt he was plugged into probably a 20 or 30 amp RV 110 outlet. Just it was a long ways away, and he's running a driver and a power supply for the driver and lights in the shed, and he said he had a computer out there and everything. There's a lot of data that goes into that, right? And to have the opportunity to vindicate yourself in this hobby is very rare. And it wasn't the guy that shot, it wasn't Stick. He was just working with what he knew. I'm just working with what I know, and I've learned a lot since I built this box. So we got to keep that whole picture in our minds. Okay, I'm not saying anything negative about Stick. I'm saying negative stuff about guys on Facebook. Facebook, I don't feel is very good for the radio hobby. I mean, it has good points in it. Like if you come into my group where there's zero trash talking, not a lot of belittle anybody else, and the whole point behind the group is to help each other. There's lots of good groups like that. There's several sideband groups that I'm part of. Like one of them is led by my buddy Richard Milner. He doesn't put up with any of that crap. You go in there and start acting a fool, your ass goes away. Go be a dick elsewhere. I don't know about you, I'm just kind of tired of the whole dick Facebook syndrome. Man, we're just going to grab this guy, drag him up on the cross for no good reason other than to sound important and relevant. How about this? Instead of spending so much time being a keyboard warrior, how about you go and turn your radio up a little bit more? Work on your station. I don't know. Novel idea, right? But hello, 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. Hello, 1 2 1 2. Oh, we got to 49.8. Hello, 2/10 of a volt under. Hello. Come on. Come on. I love it. Absolutely love it. Way to succeed and move forward. Man, good stuff. Good stuff. Well, shitballs on us Nikes. We still got a long ways to go. We finally got it working right again. Now, in all fairness, we know the input transformers were changed. These are cut in my way, and they were wound with the wire that I put in them, and the numbers of turns hadn't changed. So I got to go with the fact that this thing had a flaw in one of the transformers from the word go. Right? So, okay, we fixed the problem. Instead of just abandoning the section and saying the power supply isn't adequate, we worked through what the issue was. And we did it together right here on video. You, me, together. Now the hard part. The hard part is I got to repaint the face of this cabinet because it is scratched, beat up. It's all covered in scuff marks. Scuff marks, scuff marks. It's all covered up in scuff marks. We're running the amp without nowhere. It's all covered up in scuff marks. Scuff marks, scuff marks, scuff marks. Okay, to make this match, I'm going to go ahead and I'm going to tape off on the inside of the box. I'm going to tape all of this back to here. I'm probably going to do an edge tape back here across the back side of the cabinet. Across this edge. Back side of the cabinet's in really, really good shape. But this top leading edge back here, not so hot. And when we put the lid down, it looks like poo. I said it looks like poo and it goes like stink, but it is what it is. Hello, 1 2 1 2 1 1 1 1 1 1 1 1. Hello, 1 1 1 1 1 1 1 1 1. Everything's happy. I'm happy. Amplifier's happy. No smoke is coming out of it. 1 2. To Mr. F, the new owner of this box, please keep in mind that this is about a 3,500 watt amp, 3,400 watt amp max. If you cruise this thing anywhere from 2,800 to 3,000, you're not going to have any problems with it. Keep an eye on your exhaust air temperature, and I can't see you having any kind of problems with it whatsoever. Keep your dead kit about, I don't know, 500-600 watts. And just let it swing. Just let it go. 1 2. At the end of the day, you won't be disappointed. Okay, let's clean up the paintwork. And then I think we're going to convert this over to 220. So what that was a compilation of FLIR shots that I just took after shooting this last little segment of video, where I'm pushing on the amp really hard. There's no air cooling on anything. Not the transformer cores, not the heat sink, nothing. And I wanted to show, one, that the output balancing resistor was not hot, because that shows us if we have imbalance. That's going to get hot if there's any kind of imbalance in the circuit whatsoever. Ice cold. I want to show that the transformers were not hot. I mean, 119 degrees is not hot. Hot is 150, 160 degrees. These have been sitting here running for hours as I've been sitting here playing with it. They have a good idle soak temperature. As the transformer's just sitting there idling, it's going to get a little bit warm. So then to put it underneath a load like that, and then I wanted to show how hot all the components were. So what you're looking at is the first shot was a back aerial shot like this. The next shot was a balancing resistor. And then I think the third or the fourth shot is me showing the whole transistor path here. You can see all the transistors are uniformly warm. All the parts are at the same temperature. That's just from radiant heat coming back to all the components. The thing's in balance, it's running smooth, it's got good input, looks good on the spectrum. Oh, I haven't shown that yet. So I'm going to show you a phenomenon called proximal bleed. The cabinet is open, right? I'm working in an isolated grounded dummy load system over here, and that's what the amplifier is going into. This is my, like one of my monitoring stations I've got. It's set at plus and negative 250 kc, so 500 kc's wide. And we're just sitting here playing with it into a dummy load, right? So here's radio, 1111111 at 11111. Now here's amplifier at 111111111. Taking into account that antenna's just a couple hundred feet away, still it serves as a valid data point. If I had anything that was off the primary frequency out to 500 kc's each wide, it would show up, right? Okay, so now let's go look at the spectrum analyzer. So, okay, once again, radio, amp. 111111111111. Hello. It's clean. It's clean. I turned the camera off because I had to turn the spectrum analyzer off. I had all that shit shut off because I was getting ready to get this thing taped up. So now that we've got all of our basic units of measure covered, I can go ahead and we can break all this down and we can tape off the inside of this cabinet with some painter's tape in reverse and clean up the paintwork on this thing. Got a little bit of work I got to do on the face because there's a little bit of glue left over from when they peeled the original sticker off. They just peeled the sticker off and then it collected dirt. So I got to get that cleaned up and then we can get the faceplate repainted and then we'll do the lid. Well, we did away with the curling breaker here, or cutting switch made by curling. The curling switch ink, pardon me. Did away with that. So now what we replaced it with is two 110 volt, two 10 amp fuse holders. So these two are on their own separate leg out of the 220. So these are getting 110, these are getting 110. So our output voltage is the same, at 61 volts. And we're hitting this with the 490. So with about, well, no, about's about it. Let's go to 1X. Put the amp in standby. 1-1, hello. Right at about 200 watts of drive. Let's go down to 5X, so 5,000, 4,000, 3,000, 2,000, 1,000, and so on, reading that middle scale. Turn the amp back on. Hello, audio. I'll say it's a little happier on 220, wouldn't you? Hello. About 200 more watts out of it. So 200 watts of drive, we're getting 3,200 out of it, which is good. Good. Now, if I remember correctly, if I sat there and I had hello for a long period of time, it was dropping to 51 and some change. If I'm wrong, correct me in the comments. Hello. I'm getting a couple more volts out of these transformers. It goes to make sense, doesn't it? I think it does. Less current drop, we're jizzing the jam. Okay. So what we did to the face of this thing is we went ahead and we got rid of the ugly rocker switch that was on the front end of the breaker here, this guy. And to cover up the hole, I went ahead and I installed a jet rocker switch. And then down here in the bottom, there's going to be yet a separate screw. But I didn't bother putting the screw in because now that we've got this all working and we've got the fuse holders in place, I finally get to do the last step of the process. Yeah, that's right. That's right. I'm going to paint it. So that means I need to undo this broken switch, which is for the fans. And me personally, I want to delete this. This is going to go away. So I got to undo the activate standby switch. We're going to squirt some paint on this thing. Squirt some paint on the back. Pay special attention to these areas here, like here and this top edge. And we're gonna give her a boob job. We're gonna take our headlights and set them pointing down the ground. We're gonna lift them back up so they're pointed kind of forward, but not up. Forward, not up. Whatever we do, we don't want to end up where one's forward and the other one's pointed up, or give it walleye vision. Walleye vision's never good. And if you think I'm still talking about the amplifier, it's So yeah, fun part about being an amp builder. I just put down the first layer of paint, so we're kind of at a standstill for an hour. Yeah, fun times. So here we are about an hour later. I just went and put the second layer of paint on that thing, and I thought, well, I can show you this. This is the same scuffed up, beat up cabinet lid that we took off that thing. It's smooth as glass, and I got rid of those stupid blue fans that don't move any air. Let's see here. Underneath, I built an independent regulator circuit for each one of the fans. Those are these nice sun-ons that move a ton of air, but they are fully regulated, and we've got our resistors in there to lift the fan above ground, which will help protect it from RF. But yes, I sanded this thing all the way down to the bare metal, and then put an epoxy primer on it, and it's got 4 layers of really good paint on it. So yeah, isn't that neat how the lights are casting shadows? This is all perfectly painted. I'm just really excited to have the opportunity to finger this amplifier again and play with it. So let me go kill a couple more hours of time. I know what I can do. I can return phone calls. Yay. Yeah. You come in here beat up, cabinet bent, fingernail polish on the screws. Just leaving out of here with an all new glass black paint job with screws that are color matched. I'm not going to be able to ship this for a couple days. I got to let this paint harden a little bit. Otherwise, everywhere the bubble wrap hits it and the air bladders that go on this thing touch it, it'll look like an octopus laid its arm on it, and it'll leave little rings all over the place. It'll be a couple days before I can ship this thing, but I mean, this thing turned out pretty. It's quiet. And with the drive of basically a one pill, a single 2290 one pill, it's a couple hundred watts. I mean, it gets up there, 3200 watts, no problem. 1-1, hello, 1-1-1-1, hello. It's been a long road, my man. I spent more time on others, but this one was special. It was special when I built it, and it's even more special today. It's the only one that I ever built like this. The other 8-pill that I have built, it's got a switching supply in it, and it was built completely differently than this. It's a good old box. And I truly feel, I truly feel inside that you're not going to have any kind of problems with this. Just put a couple hundred watts in it and be happy. Run it. Be peaceful inside, knowing the fact that this thing, it does like a retarded amount of power, but just the smallest amount of drive. I mean, seriously. It is a 3,500 plus watt 8-pill. Which requires basically a striker drive or a 955 drive or something like that. Just 200. I wouldn't go past about 220, maybe peaking at the most 300, but I would really strongly suggest around 200. Well, I got this one done, and now I got to go jump onto something else. I sincerely say thank you guys for being here with me and following along with the saga. Sitting here and watching the videos, seeing what's going on. I honestly, from the bottom of my heart, I say thank you to every single one of you guys. There's more to come. There's always more to come. And that's because of all of you and all of your support. Gentlemen, I gotta go. We'll see you. Click, click.